Hello everybody, and today we're going to be going through the Leetcode question, merge sorted array. This is an easy question. It is, the tags I'm pretty sure are two pointer and array. From this is from on top of my head, if I'm not mistaken. And yeah, so we are given two integer arrays, as we can see right here. So we're given two integer arrays, nums1 and nums2, sorted in non-decreasing order. This is important. And we're given two integers, m and n, representing the number of elements in nums1 and nums2 respectively. We have to merge nums1 nums2 into a single array sorted in a non-decreasing order. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. So we can't make another function. We can't make another array, right? Usually we could, like, usually how people usually do it is just, merge, like you have a separate array and we just add the elements to a separate array, but we can't do that in this case. To accommodate this, nums1 has a length of n plus n. Okay, so because now we know that m is the length of, okay, wait 1 second, actually, let's just keep reading it. Where the first elements m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. Okay, I see. So now that so in example 1, we're giving an input of nums1, which is 1 2 3 0 0, m equals 3. We're also given nums2, 2 5 6, and n equals 3. So m is equal to the number of elements in nums1, the real number. So it's not including the 0. It's only including 1, 2, and 3, right? So m equals 3 just means the number of elements that are actually included into the array, the real numbers that we're going to be including. The zeros don't really matter in this case, as it's said here. The last n elements are set to 0, right? Since n is 3 as well, so these are the last 3 elements and should be ignored. Nums2 equals 2 5 6, which is n equals 3, so there's 3 elements in nums2, and the output of this after merging is 1 2 2 3 5 6. Here there's also an explanation. The arrays we are merging are 1 2 3 and 2 5 6. The result of the merge is 1 2 3 5 6, with the underlying elements coming from nums1. So the underlying elements are 1 2 and 3. Right, in example 2, we have nums1 equals 1, m equals 1, nums2 is an empty array, and then n equals 0, and then the output is just 1. And then they're just merging the 1. And they're doing example 3, it's kind of similar. So nums1 equals 0, nums1 equals 0, and the m equals 0, so I guess they have no elements. They have no elements in nums1, and nums2 equals 1 in the array, and n equals 1. And the output is 1. Yeah, a lot of 1s. Okay, so what we can do, so we know it's sorted in non-decreasing order. That's important, right? It's sorted in non-decreasing order. Okay. The best thing that we can do is, so obviously before I get into the best solution, let's start with the trivial solution, right? The thing is, right, the final sorted array should not be returned by the function, but instead stored inside the array nums1. Because the thing is, if we did this normally, let's just say we had another array. So let's say we had another array, which is our empty list. So let's say this is our empty list. And we had 1 2 3 and 2 5 6, right? We can have a pointer at each one. We can have a pointer at the last element of each array. So we have a pointer right here, and we can have a pointer right here, right? And whichever is bigger, we can just add it to the new array, right? That's the most common solution, but we can't do this, right? So then I'll just go through this solution just so like you guys have an idea of what I'm talking about. So let's say we compared these numbers 6 and 3. 6 is obviously bigger, so we add 6 here, right? And then we move this pointer to the 5, right? So we just cross that out, and we move that to the 5, right? So now we have 5 and 3. 5 is obviously bigger than 3, so we move that here. We cross that out, and we're left at right here. So now 2 is 2 bigger than 3? No, this is bigger. 3 is bigger than 2, obviously, in the nums1. So we put that here. Let me just put commas here so we know how to separate it. And we cross this out, and we add 2. Oh, we put it here. Let me just, yeah. So now we're at 2, right? 2 and 2. 2 and 2 are the same, so we can just add each other one. We can just add whichever one. 2, and we'll cross this out. And is 1, now we're at 1, and that was 1 bigger than 2? No. And then we add another 2, and then it's, obviously we cross this out, and then it becomes 1. My bad, I have to make this a little bit bigger. I'm just write it again. So it becomes 1, 2, 2, 3, 5, and 6. Right? This becomes our new array. If we were returning an array, but we can't, right? So this is the simple solution. We use more space, obviously, but we can't do this solution, right? So let's do the most optimal solution, right? Right, so using the same example that we had before. So let's say we had nums1, which is the same one. So let's say it was 1, 2, 3, 0, 0, 0, right? And nums2, we're going to use the same example. I'm not going to change anything. Equals 2, 5, and 6, right? And basically so we can't use another array, obviously. So what we're going to do is we're going to keep track since nums1, since they said here in the question, nums1 equals the length of nums1 and nums2, so m plus n, right? Because since we know that nums1 equals m plus n, and n equals nums2 dot length, right? So what we can do with that information, since we know nums2, the n equals the length of nums2, what we can do is we can have not a pointer, but we can use the last element here as our increment. So we can say, for example, we can use the exact same logic that we did before. So we have a pointer here, which is here. So we'll call this left, call this right, pointer right here, and we can have a counter. So the counter would be here, right? So now, for instance, we're still doing the exact same logic as we did before. We're comparing 6 and 3. Is 6 bigger than 3? Obviously it is. We replace this last element 0 with 6. Then we move this counter. Let me just put a different color for you so it's a lot more easy. Okay, that's a little weird. I don't know why it's changing everything. Okay, so now we move this, right? We move this, and now counter becomes C, right? Counter moves down, so it's now, so, and we also would get rid of this. Get rid of this, and then the right pointer becomes R. And now we compare again, right? So is 5 bigger than 3? 5 is obviously bigger than 3, so we move that here. Put that here. Just for consistency, we're gonna make the 6 into red as well. It's easier to read. And now also we cancel out this pointer and we move it down. So it becomes to right. We're using the exact same logic as we did before, but the only difference is we're not storing it in a separate array, but we're using it in the nums array, right? And then we take that out. We decrement counter because we can't use the same index, and we put it down here, right? So is 2 bigger than 3, or which one's bigger here? 3 is obviously bigger. So what we're going to do is we're going to put it here. We cross this out, and then we move the pointer down here. Is 2 is the same as 2 and 2 are the same, so we can use each pointer, doesn't really matter. Cancel that out, becomes L. And now is 1 bigger than 2? No, 2 is obviously this right pointer is bigger, so we put that right here. Cancel that. We're done here with this, And now we have this last element, and this just stays the same. We don't really change it. We don't change anything here. So now our final merge sorted array becomes 1, 2, 2, 3, 5, 6, right? That's the visual high level explanation of this. It's the exact same logic as the one I just showed you before, but the thing is we're storing all of our values in nums1. Since nums1 will always be n plus n, it'll always have the same length, right? It'll always be bigger. Okay, so now let's get to the coding solution. Coding it might look a lot more simpler, and it might make more sense when we code it. So first we're going to use the counter, right? We're going to use that counter. So length, no, we'll just do n plus n, since we know that's the length, minus 1, right? Minus 1, since the indexing starts at 0, right? M already equals, so now we can do, we already need a pointer. We're going to call this L equals m minus 1, and the right pointer equals n minus 1. Because why we're doing minus 1, the index obviously starts at 0, so the last element is going to be 2, so that's why we're doing minus 1. And now we're going to have a while loop, so while L is greater than -1, and in case we finish at nums2, and then if we don't do this and, we might get an index out of range error, right? Right is greater than -1. Now what we're going to do, we're going to check to see if whichever pointer is bigger, right? So if nums L, we'll do greater or equal to nums R nums1 equals C. Now we're saying if nums, right now we're saying if the nums L, oh, I gotta put 1 first and then put 2, right? Because it's the first element, this is nums1, nums2, right? And so basically what we're saying is the last element, the real element, greater than the element in is the left pointer greater than the right pointer? Is the left pointer greater than the right pointer? Okay. Sorry, I said that, it was a little confusing. And if it is, we're going to say nums1c, which is our counter. And we're also going to do L equals L minus 1. We're going to decrement L. So now we're just going to copy this since it's almost exactly the same. I'm going to copy this. Okay. Now we're going to change this. Now we're going to say if nums2 is greater. If nums2 is greater, R equals R minus 1, C, and now we're going to decrement C. Each iteration we're just going to decrement C because we don't want to use the same index for the new array for nums1, right? Okay, now we're going to run the code. What did I do? Oh, I misspelled nums2. I probably did that here. Misspelled it. Okay, so this is actually what I wanted. This is actually so we got the wrong answer. Let me just put that a little higher for you guys. Case 1 was successful. Case 2 was successful. Case 3 wasn't successful. This is actually what I wanted and to show you guys. So there's actually an edge case that we need, right? There's actually an edge case. And let's go back to my example right here. So let's say, for instance, this was, where's the eraser? Let me just find the eraser. Okay, let's say, for instance, this was 2, right? This was actually 2, and this was 1. This one was 1, so I'm just gonna get rid of this. Oh, I didn't know I could do that. This was actually 1. This was actually 1, right? And if this was the case, what would happen is, okay, so let's say we got through this loop, and okay, so let's say this was the case, and let me just start this again so it's more simple for you guys. Okay, so let's say this was the loop, and then it would be 6. It would still go. So let's say it started at. So let's say we start from the beginning, right? Is 6 bigger than 3? So it'd go here, cross out it again. Is 5 bigger than 3? Yes, go right here, cross that out. It becomes right again. Is 3 bigger than 1? So that would be here. Cross that out. Is 2 bigger than 1? Yes, it is. Right here. Is 2, we cross that out. Is the left one bigger than the right? Yes, it is. So then this becomes 2 as well. And now we're left with, we actually finished going through this nums1. We finished going through it, and now it's going to exit our while loop, right? It's going to exit our while loop, because if you remember, here we said while left pointer is greater than -1, right? So we're actually done, and it's going to miss this element, right? And this is actually the case here, right? Since the nums is 0 and m equals 0, it's going to miss this. That's why the output was 0. And this is the answer. If you guys have any questions, let me know down in the